Hi, everybody. Hey, I put up a few little documents that I think will help you get started if you're having some trouble with MATLAB. So we have MATLAB for beginners, using MATLAB for the first time, and using the command prompt in MATLAB. And each one of those videos is very short, less than the longest one is 11 minutes long, and I think they'll get you a good background. The other thing I wanted to do was to record this video to talk about just what we're doing with the program, what the homework assignment is kind of about. And to that end, I've written this document that I've put on your Moodle page, and I'd like you to take a look at it as we go. So I'm going to pull it up right now, and you have a copy of this on your work. So this is a 3-page document. And the purpose of the first homework problem that we're writing is to convert between 4 different temperature scales. If you watch the Weather Channel, you may notice that sometimes the temperature is given in degrees Fahrenheit or degrees Celsius. And those are these two numbers right here. So basically, Fahrenheit is the scale that we use in the United States. Celsius, or sometimes it's called centigrade, is the scale that's used in everyday use pretty much everywhere else in the world. And then Kelvin and Rankine are 2 scales that are used by scientists that are based on the Fahrenheit and Celsius scales. But basically, the way it works is like this. There are 3 different important points, then one point I always like to bring up. But basically, water boils at a particular temperature, and at sea level, that's 212 degrees Fahrenheit. Water freezes at 32 degrees Fahrenheit, and that's sort of the scale, that's sort of the range of temperatures that the Fahrenheit scale was developed around. Now, in the rest of the world, this is kind of a metric-y thing. Instead of having 32 being water freezing and 212 being water boiling, they divide it up into hundreds, so that water freezes at 0 degrees centigrade and boils at 100 degrees centigrade. Now, the thing that I wanted to point out to you is that 212 Fahrenheit and 100 centigrade are exactly the same temperature. And similarly, 32 degrees Fahrenheit and 0 degrees Celsius or centigrade are exactly the same temperature. These scales, Kelvins and Rankines, are built on these ideas. The size of a Kelvin degree, 1 Kelvin degree, is the same as the size of a centigrade or Celsius degree, and the size of a Rankine degree is the same as the size of a Fahrenheit degree. But the difference is that instead of 0 being where water freezes in the case of Celsius, or just some arbitrary number in the case of Fahrenheit, the zeros on these, 0 degrees Kelvin and 0 degrees Rankine, mean something scientific, which is absolute 0. So absolute 0 is a very, very cold temperature. It's a temperature that we don't ever really reach in everyday life. It's something that can be approached in a laboratory. But what it is, it's a number where the energy state of the material that's being measured, or the medium that's being measured, is at a minimum. So it's a very, very, very low number. And so it's set so that 0 degrees Rankine, 0 degrees Kelvin are both absolute 0, and so 0 Kelvins and 0 Rankines are the same temperature. It's just that the size of a degree Rankine and the size of a degree Kelvin are different. They're the same size as the Rankine is the same size as Fahrenheit. Kelvin is the same size as Celsius or centigrade. So that means that absolute 0 is all 4 of these things. If we call it Rankine, it's 0 degrees. If we call it Kelvin, it's 0 degrees. But in centigrade or Celsius, it would be negative 273.01 degrees. And in Fahrenheit, it's negative 459.67. So this is what we're doing, is we're saying if you're given some data, you're given a temperature in degrees centigrade, for example, what would the number be? If it's, say, 40 degrees centigrade, what would it be in Fahrenheit? What would the number be in Fahrenheit? What would the number be in Kelvin? And what would the number be in Rankine? So that's what the program that we're going to write for homework 1 does. It takes those numbers any one of those inputs, a Fahrenheit, a number in degrees Fahrenheit, a number in degrees centigrade, a number in degrees Kelvin, or a number in degrees Rankine, and changes it or converts it to the other three temperature scales. So the other point that I always make is it turns out that negative 40 degrees Fahrenheit is exactly the same temperature as negative 40 degrees centigrade. And for those of you that are raised in the mountainous West, you know that 40 degrees, negative 40 degrees is just really cold. So I always like to just point out that they're the same number. It doesn't matter what the temperature scale is. It's just cold. So if you think about this being a thermometer, each one of these lines, we can think of it as being a thermometer, where this thermometer measures in degrees Fahrenheit, this measures in degrees Celsius, this measures in degrees Kelvin, and this measures in degree Rankine. These points are the same. Water was going to boil at each of these temperatures on those different scales. Water is going to freeze at each of these temperatures. Now, the just cold number is only for Fahrenheit and Celsius, but absolute zero is each one of these four numbers. So you can think of these as being, like I said, as being temperature thermometers. And I drew a point down here because we cannot get below absolute zero. It is an absolute, we can't go below it because minimum energy, I don't even know what that would mean. If it's the lowest possible energy state at absolute zero, we can't go below that because the lowest energy is the lowest energy. But on the top end, I drew arrows rather than points, indicating that you can keep going up and up. There's no theoretical limit to how high those numbers can be. All right, so what do we do with this for our program? Well, the first thing is each one of these temperature scales has a formula that converts it to the other temperature scales. The most commonly used ones are between Fahrenheit and Celsius and Fahrenheit. So basically, I'll just show you this. I've got it organized on the third page a little bit differently, but just to give you the overview. If you're given something in degrees Fahrenheit and you want to change it into degrees Celsius, you take the Fahrenheit number, subtract 32 from it, and then multiply it by the fraction 5/9. Well, if you put the fraction 5/9 into your calculator, if you like decimals better, you'll see that 5/9 is the same as a repeating 0.5. So this number is 0.55555 and goes on forever. So in other words, you can take Fahrenheit degrees minus 32 and then take that number and multiply it by 0.55555. And then last but not least, you can take Fahrenheit minus 32 and divide it by 1.8. All three of these are exactly the same, but they're all used to get degrees Celsius from degrees Fahrenheit. If you're going the other way, you take the degrees Celsius, multiply it by 1.8, and add 32, and you get degrees Fahrenheit. Now, the one thing to notice is, if you remember order of operations, here we have parentheses, so you do the subtraction first, then you multiply or divide. But here we don't have parentheses, so you do the multiplication first, and then you add. All right, to convert from Kelvin to Celsius, since I said they're the same size of degree, all you do is you take kelvins and subtract off 273.1 to get Celsius, or you take Celsius degrees and add 273.1 to get kelvins. And Rankine and Fahrenheit have the same sort of a relationship, where if you have degrees Rankine, you just subtract 459.67 to get Fahrenheit. And if you have Fahrenheit, you add 459.67 to get Rankine. All right, so on the last page of this document, what I show you is the program will ask for an input in either degrees Fahrenheit, degrees Celsius, degrees Rankine, or degrees Kelvin. And then we'll calculate the other three. So this is what you have to tell MATLAB to do. First thing is you ask what is the scale that you're using, and you would input F, C, R, or K. Then if it's F, you would use these three formulas to calculate how many degrees that is on the Celsius scale, on the Rankine scale, the Kelvin scale. If you're given a temperature in degrees C, here are the formulas that you use to change it to the Fahrenheit, Kelvin, and Rankine scales. And similarly down here, if you're given Rankine, given Kelvin, that's how you convert to the other scales. All right, so like I said, this document is available for you right here. Here are the three very short videos that I think will be very helpful to you as you're getting started. And then I'll post this video right here, just right below the other three videos, or the other four videos, excuse me, and right above the homework number 1. So I'm going to record another video within a day or so that will show you how to do this in MATLAB, how to take Dr. Floyd's code and write it as a MATLAB program. And then after that, I'll post it to this place as well. And then I will send out a doodle poll so that those of you that want to can meet with me via Zoom, and we can talk about any questions you have regarding the videos and the documents. All right, thanks so much. Have a great day.